Good morning, students. My name is CH.S.V.PRASAD, working as senior lecturer in electrical department at Government Polytechnic, Yadirgut. I am handling the chapter AC motor. In this case, we will continue the fifth chapter, that is starters and speed control of three-phase induction motor. In the last class, we have covered the circuit diagram, that is how you have to draw the circuit diagram. So for drawing the circuit diagram, which test results are required, how we will conduct the test, and how we will use that parameters to draw the circuit diagram, and after drawing the circuit diagrams, how we can calculate the different parameters. And we have solved so many problems also. So today we will check starting condition of motor and necessity of starter and functions of starter. Next, methods of starting of three-phase induction motor. Next one is types of starters. Next is starter function with current and torque curve. So these things we can cover today. Note down these parameters. So how we can start the motor? We can start the motor by using starter. So why starter is required? So is it not possible to start the motor without starter? Okay. So what happen if you connect the motor directly to the supply without starter? So we can cover that one. That is starting condition of a motor. So as a name only it says it starts the motor. So already we studied in our previous class, that is what are the covered DC motor starters, that is 3-point starter. So why it is required 3-point starter? 3-point starter is required to start the motor and at the same time to limit the starting current. So 3-point starter is used in DC motor. So what is the function? It limits the starting current. So for a three-phase motor, if you see a induction motor, we have slip. Yes. So slip is S is equal to ns minus n by ns. So that is 1 minus ns by n by ns. So that is equal to, at starting condition of motor, n is equal to 0. So that is motor speed is 0 at the time of starting. So at the time of starting, the speed is 0. N is equal to 0. If you substitute n is equal to 0, then what is the slip? Slip is 1. Slip is 1. Suppose the motor speed is NR, maximum NS. NR is equal to NS. So that is 1 minus 1 is equal to 0. That is slip is 0. So for rotor induced EMF at, at the time of starting, induced EMF is equal to E is equal to ER. That is rotor induced EMF. So at the time of starting, as speed is equal to 0, so E2 is maximum. So when E2 is maximum, then what happened? The EMF circulates very high current through the rotor. So this EMF circulates very high current. Why? Because S is at the time of starting, slip is equal to 0. So the starting current of the three-phase induction motor is equal to SC2 by square root of R2 square plus SX2 whole square. So I2 is maximum. So why? At the time of starting, E2 is maximum and slip S is maximum. So starting current is 5 to 8 times the full load current. So this full load current will damage the motor winding. So generate large voltage drop. High current may affect the working of the other equipment connected to the same line. Suppose if you on the motor and it's drawing more current at the time of starting, and then what happened? It draws more current that flows through the winding, and and because of this high current, the winding will be spoiled. It will burn. So, and not only the motor will affect the other motors which are connected to the same bus bar will also be affected. So for them also the supply is interrupted, disturbed. So then what happened? What they will do? So to avoid this, we have to use so that the current is disturbing the because of this high current, high starting current, the other equipments are affecting. So starting current is 5 to 8 times the full load current. So we have to limit this high starting current. Therefore, to limit this high starting current, so by the motor, starter is necessary. So these are the drawbacks of the if you connect the motor directly. So to limit these all values, we have to use the starter. So when we use the starter, it will limit the starting current as well as other effects. So what is the function of the starter? So for the starter function is to limit the starting current at the motor. So why starting current is high? The induced EMF is high. So this induced EMF at the time of starting is high. Why? Because S is 0. S is minimum. So when S is minimum, automatically, sorry, S is 1. Why? Because speed is 0. When speed is 0, slip is 1. So that is induced EMF is equal to starting EMF. So that is E2. So another application is to start and stop the motor. So and next one is automatically off and on when it is required. So next one is to protect the motor and other equipment from overload. So that means because of this motor, other applications which are connected will be affected. So these are the functions of the starter: to limit the starting current, to start and stop the motor, and to permit automatically on and off when required. Next one is to protect the motor and other equipments from overload and low voltage. So what are the methods of starting? So to limit this high starting current to a safe value, two methods are used. One is by reducing the voltage to the stator, or by adding external resistance in the rotor circuit at starting. So by applying reduced voltage to the stator, or by adding resistance in the rotor circuit at starter. So for getting the above condition, so which starter you have to use? So there are four types of starters. So for starting three-phase induction motor, so for suppose for squirrel cage motor, so totally we have four starters, and four starters. These three are only used for squirrel cage rotor. This starter is not used for squirrel cage rotor. So they are: first one is DOL starter. So in this case, full voltage is applied. Next one is auto transformer starter, which applies reduced voltage for the to reduce voltage to start. Next one is star delta starter. In this case also, reduced voltage is applied to start the motor. So then what happened at the time of starting? When I apply reduced voltage, automatically the starting current also reduces. Next, fourth one is next for slip ring rotor. Which starters we can use? First one is DOL starter. So next one is auto transformer starter. So in auto transformer starter, reduced voltage is applied. Next one is star delta starter. Here also we apply reduced voltage. Next one is rotor resistance starter. So that is full voltage starting. So these starters are used. So all the above four starters are used for slip ring induction motor. So, how the current is reduced by using the starter? So let starter be dual starter. So that is full load torque and full load current. So this shows the dual starter curve, that is current versus torque and rotor speed. So to draw this one, so which is full voltage stator current and full voltage starting torque. So from this, when full voltage is connected across the stator terminals of induction motor, large current is drawn by the winding. It is because at starting the induction motor behaves like a short circuit transformer. So this high current will, however, be gradually decreasing to its normal value as the motor picks up speed. So as the motor picks up speed, this external distance is automatically removed. So whereas in dual starter, it is connected to the motor directly. So directly connected to the motor. So starters. So why starters is required? Starting of induction motor involves change in its state, that is from rest to steady state speed of rotation. That means it starts rotating from 0 speed. So the process of starting, one of the most important is its operation. So we covered what is the necessity of the starter. So when three-phase induction motor directly connected to the supply, then what happened? It will take a very high current, that is 6 to 8 times its rated full load current at the time of starting. So this heavy current may not impact the electrical stresses that are severe as those experienced by other motors. But such a large current flows through the motor winding will causes a large voltage drop in the supply system. And not only the large voltage drop, other machines connected to the same supply will be affected. So therefore, it is recommended that a large three-phase induction motor can be started with reduced applied voltage at the stator terminals. So the main disadvantage of starting with reduced voltage is large reduction in starting torque. So then what happens if you reduce the voltage, automatically torque also reduces. Why? Because T is proportional to V square. So such a great reduction in starting torque is permissible with depend upon the application. So the following are the common methods of starting three-phase induction motor. So first one is direct online starter. Next one is auto transformer starter. Next is star delta starter. And fourth one is rotor starter. So if you are using DOL starter, when full voltage is connected across the stator terminals of induction motor, large current is drawn by the winding. This is because at starting the induction motor behaves like a short-circuited transformer. This high current will however be gradually decreased to its normal value as the motor picks up speed. So then what happened? The current drawn by the motor when started direct online. That means the voltage is full voltage is applied. The deval starter contains push button type deval starter. It is simple, inexpensive, and easy to install and maintain. It consists of start and stop button with its contacts will be there, and it is not only start the motor, it also protect the motor from overload and underload. And another application is it can be used for on and off purpose also. So then what happened? So if you press the on button, the the contactor coil C becomes energized through off switch, and overload relay will acts and comes in, contacts are closed. So this closes the main contacts and the motor gets connected across the supply. So the motor continues to get the supply until the on button is open. Since the contactor coil gets the supply through the contactor TT, therefore it is called hold on coil. So suppose if you press the off button, then the coil get de-energized, the contacts are open. If supply fails or line voltage drops below value, then contacts open and is called under voltage or no voltage protection. In case of overload on motor, the contacts of overload relay will open and stops the motor. So that's why devial starter of a three-phase induction motor above 4 or 5 kilowatts are used. So that is the purpose of DOL starter. Suppose if you take auto transformer. In auto transformer, what we will do? In auto transformer, we will apply reduced voltage. An auto transformer starter consists of auto transformer with suitable connections. So which connections we have? Either we have either we have reduced voltage and we can connect to the supply. So how we can connect? When the switch is, if you put switch is in start position, then reduced voltage is applied across the motor terminals. So when the motor picks up the speed, when the motor picks up the speed, motor picks up the speed and motor reaches 80 to 90% of the speed, then 50 to 70% of the speed, then the starter is disconnected from the supply. So, so it will comes automatically. So when the switch is on start position, then a reduced voltage is applied across the motor terminals. When the motor picks up 80% of its normal speed, we have to put the switch on running condition, that is run condition. Then auto transformer is cut out of the circuit and full rated voltage gets applied across the terminals. So the circle diagram shows the auto transformer starter. This can be made to operate automatically controlled starter so that the contact switch from start to run position of the motor has to change when the motor reaches 80% of its rated speed. So it also contains overload protection relay as shown in figure. The switch, one switch will be there which is kept for small motors and it is in oil brake type which supplied reduced voltage. So another type of starter is star delta starter. So this type of starter is used for motors which are designed to run normally with delta connected stator winding. So in this case what they will do, they will bring all the 6 terminals of the stator winding and connect it to the two-way switch as shown in figure. At the instant of starting, the two-way switch is thrown to start position which connects the stator winding in star. Then each stator phase gets reduced voltage, that is V by root 3, where V is the line voltage and which supplies a reduced current of 1/3. So when the motor runs and picks up the speed, the two-way switch is thrown to a position of delta. So the motor is on line voltage. In this connection, the star delta starting, we have to take care so that the sequence of the supply connection to the winding terminal has to follow. That is changing from star to delta. We have to follow the phase sequence. Otherwise, the motor will run in automatically. An automatic push button starter will be there, which is used as a time delay relay. That is, star to delta connections takes place automatically. So this type of starters are employed for starting induction motors operating 4 kilowatts and 50 kilowatts. So when we use these starters for different applications, for different type of motors, so that depends on the rating of the motor. And next last one is rotor rheostat starter. So in this method we have to use a variable resistance, that is variable star connected rheostat is connected to the rotor. So this rotor winding through these slip rings are connected to full voltage at the stator, but we have connected some external resistance in series with the stator. So then what happened? At the time of starting, the handle of the starting resistance is at a start position, so that maximum resistance is added in each phase of the rotor circuit. When we are adding maximum resistance in series with the rotor, then what happened? Automatically the current will be reduces. So this reduces the starting current of the motor. So as the motor picks up speed, we can gradually or reduce the starting resistance, or we can cut it. When the motor reaches its normal speed, then put the handle in run position by cutting the entire resistance from the rotor circuit, and slipping terminals are short circuited. So there will be some interlocking to sure to ensure proper sequential operation of the switch and starter. So this method not only limits the starting current but also increases the starting torque. So why? Because the torque is directly proportional and depends on the resistance. So in this rotor resistance starter, what we are doing, we are adding some external resistance in series with the stator. When we are adding some resistance in series with the stator, then what happened? The overall resistance is increases and the current is reduces. That is starting current. So when the starting current reduces, then what happened? Automatically the motor run starts with a safer value. When the motor reaches to a value that is 70 to 80% of the rated speed, then we gradually reduce the resistance. Then what happened? When we gradually reduce the resistance, automatically the resistance which is across the stator will be reduces, and the speed increases. So as well as motor speed increases, will gradually reduce the external resistance. So when the motor reaches 80 to 90% of the speed, all the external resistance is gradually removed and the motor starts as normal motor. So when the motor reaches to its normal speed, then we will disconnect the external resistance from the motor. So likewise, we will the rotor resistance starter is going to work. So in rotor resistance starter, so it is not applicable for a squirrel cage rotor. It is applicable for a phase wound rotor only. Why? So why? Because in squirrel cage rotor, it is not possible to add any external resistance in series with the rotor. Why? Because the rotor winding are short circuited by the end rings. So it is not possible to add any external resistance in series with the rotor. So this method is used only for slip ring motor. It is not used for squirrel cage rotor. For squirrel cage rotor, we will use star delta starter, D-oil starter, and auto transformer starter. So these three starters are used for squirrel cage motor, and rotor resistant starter is used for slip rings, slip ring motor, where we can add some external resistance in series with the motor. So that is the purpose of we can use these starters. So when the motor reaches 70 to 80% of this speed, automatically we will disconnect the supply. So when the motor reaches 70 to 80% of its normal speed, all the starters in it starter will be disconnected and rated voltage is applied. So likewise, we can use starters for starting the motor, and not only starting the motor, it will protect the motor from overload, and suddenly if the supply is gone, in this condition also it will protect the motor. So that is the purpose of starter, and we have four types of starters. Out of these four types, three are used for squirrel cage rotor only, and the first three is used for both squirrel cage rotor and phase bound rotor, that is D-oil starter, star delta starter, and auto transformer starter. And the fourth one is rotor resistance starter, where we will add some external resistance in series with the stator winding. So that is possible in slip ring motor only, where we can add some external resistance with the stator. As the motor picks up speed, automatically the external resistance is disconnected from the supply and the motor stops. So this method is used for starting the motor. So note down the summary today what we covered. We covered slip induced in the motor and current at rotor at standing condition and necessity of starter. So that is why starter is used, and next what is the function of the starter. So what is the function of the starter? The starter is used to start the motor So, so here in this day today we covered necessity of a starter. So why starter is required? Starter is required to reduce the starting current to a safe value. And next, it will start the motor with a safe current, and it can protect the motor from overload. So, so that is the a function of the starter. So what is the necessity of the starter? The starter is necessary to reduce the high starting current. So why? Because at the time of starting the slip is 0. So why? Because the motor is at the time of starting the motor speed is 0. When motor speed is 0, slip is equal to 1. So the rotor EMF is equal to the induced EMF. So as the induced EMF is more, then what happened? When induced EMF is more, automatically the current which flows at the time of starting is also more. If the current is more, then what happened? Because of this current, it will damage the motor winding. Not in the motor winding, it will affect the other motors which are working on the same supply. So that's why we will use the starter to limit the starting current. To limit the starting current and to start the motor with a safe current and reaches to its maximum value. Suppose if your overload comes, then what happened? It draws more current. Because of this more current also, the motor winding is damaged. As the motor winding is to avoid this, we have to use the starter. Starter is used only at the time of starting condition only. So dual starter function with torque and current is explained. So how the dual starter is used and how it is connected to the supply. So if you see what they are asking questions from this lesson means they will ask explain the necessity of starter in a three-phase induction motor. Next, explain the types of starters used for starting off three-phase induction motor. What are the types? Can anyone tell? Yes, that is DOL starter. Next, star delta starter. Next, auto transform starter. And next one is rotor rheostat starter. So for tomorrow, you can note down the assignment. Explain the necessity of starter in case of three-phase induction motor. Next one is explain the type of starters used for starting off three-phase induction motor. You read these questions. If you have any doubt, ask me in the next class. Again, I will repeat and explain you. Thank you.